Go ahead.
Hello everybody, my name is Jonathan, and today I'm doing the presentation of my senior project, Stats. Just talk a little about things about me. I'm from China. I have lived in America for 5 years. When I came here, I don't speak a word of English. I just don't. I just speak Chinese to like American people, and they're confused. This is my first year to Grandview. I spent the last 2 years at CT High School, which is down Arabico. All right, let's get back to Stats. What Stats do is it always reflecting the sunlight to a certain point, and a lot of countries use it for creating energies. What they do is they use a metal bucket and fill with water in it, surrounded with hundreds of heliostats reflecting the sunlight at the metal bucket. When the water boils, it creates energy. Just quick video.
Yep.
I'm gonna kill you and every person you know. In the desert outside Seville, Spain, 360 feet of green technology is catching some rays. It may be the method that brings a massive infusion of solar energy to our cities. It's called a solar tower, and it stands as a beacon of hope in the fight against global warming. The top of the concrete tower basks in the reflection of a sea of mirrors, called heliostats. The heliostats are spread over 170 acres, and every day the sun shines, it turns the tower into an oracle of solar energy. Valerio Fernandez is the plant's engineering director.
We are at the mid, and that's it. Then we'll move on to the next one.
There you go.
So I actually don't have the video for my project to test out, but I found one on YouTube which is similar. As you see, it's keeping back, reflecting the sunlight back to the position it has been setting. And now I'm going to show you. Now I'm going to show this is actually, if you guys see if you guys see the things right here, it's spinning. When it spins, it will either push or pull. So it will control the x-axis and the y-axis. This is my logo. It represents different ideas. The mouth and eyes just sharing and taking the ideas. The color of rainbows represent infinite. So it really just infinite ideas, and yeah. This is Sage, my advisor, and he's also my uncle. He's also my partner, or I'm his assistant. Without him, I don't think I can get any of those done. And here I want to say thank you, Sage. Thank you for everything. That's my mom. Everybody says that's my sister, but that's my mom. My mom's basically give me money to do whatever I have to do for this project. And that's Kim. He's my new best friend. he's really good with C and C++. My dad is asking me some really quality questions. Things like, what does it do for, how much it's going to cost, how much will you sell for if you want to make a profit. And Jacob, he really just helped me decide things. Like things like, I'm not sure what kind of material should I use? Should I use wood? Should I use metal? Should I use pipe? Things like that. The original plan was we're using the Raspberry Pi to make this Arduino. It's more like a computer. It can be programmed in different languages, and we can use it more after the heliostats. But the plan didn't go well because we thought about how it's taking too long to restart. And if we want to just build a simple machine, and it was taking too long. So that's why we're using Arduinos. It's really good for beginners, and it works pretty well on simple machine. Over there is my code. This is how our project looks like. Sorry. To do that, we need 2 stepper motors and 1 motor controller with, of course, with the shield on it. What shield does is actually protect the controllers. That's the Arduino, and that's the Arduino shields and the controller. As you see, this is all open source. This is the RTC. This is the stick, the controller. The whole thing cost about $300. I did the math like yesterday. It was about $300. But if we have to make it again, I'm pretty sure I can control it between $100 and $150. I'm a noob for the Arduino code. So as I said, Sage really just teach me a lot. This is the original plan. I was going to watching YouTube, doing research to learn the basic of the code. And as I said, it didn't go well because we decided using Arduino instead of Raspberry Pi. I was planning to finish the code before the new year, which is January 1st. We build the things afterwards. And that's the new plan. You guys might not see it. You can see the monitor right here. So the first week, what I do is really just understand what is heliostats. What is heliostats? What is Arduino? What does it does? I researched about Raspberry Pi because I feel that's something I really just don't want to lose it. Like, I still feel Raspberry Pi is pretty cool. It's just such a small thing, and it's like a computer. Until the 5th week, we stopped the Raspberry Pi working. We stopped the Raspberry Pi and start the Arduino. The first, I spent almost 7 weeks on coding. So things like positions, altitude, wind speed, not wind speed, like angles, everything. And the thing is, like, after I'm done with my code, I have like huge trouble because the code is not verified. Then we're like, oh crap, what happened? It should be good, but it's not. After we find out, we need an RTC and motor controller for the Arduinos. So that's why I would buy the RTC and the motor controller. The 14th weeks, and we order basically just everything, like the RTC. The sad thing is, I burned one. I just broke it because I wasn't soldered good. I broke one, so that's why we decided to use the big shield. And you can see. And afterwards, we spent about 2 or 3 weeks to actually build the heliostats. We're using the wood because we thought about wood is cheap and it can be used in really a lot of different ways. The 19th weeks, we put it in test and there's nothing wrong with it. So we know we're done with the project. Thank you for watching. That's pretty much. Any questions? Yes.
When you were talking about the cost, that's obviously for a setup which is much smaller because I saw here compared to that. What do you think the cost would be if you were to upscale? Would it be comparable to other solar projects which you were mentioning in a couple slides back at the beginning?
You mean what would be the cost for now?
What would be the cost if you were to upscale it to actually be able to harness energy? Because obviously that little setup isn't going to do much.
Well, to restore energy, you need actually more than 1 kilostat. You need actually at least 400s of those kilostats for just reflecting the sunlight to that metal bucket. So I heard about it, it's more than 500 or 600 for one.
And then can I ask another question?
Yes, please.
Can I look at your source code just to see
Source code? Yes.
a few of the details? And then do you have it like posted on GitHub or something so I could look at it?
Yeah, I have my websites,
Okay.
but I didn't put it in my presentations. Yes.
So does the model actually work?
Yes, it's actually works.
with the code?
Yeah. And actually I have 2. One is automatically, it adjusts the angle automatically, and one we use joysticks. We can just play around with it, I guess. Yes.
Oh, would you be using this as like a more personal, maybe to like power a house, or would you be using it to like maybe power, let's say like a big building, maybe an airport?
I think we need way more heliostats to power a house or things like that. But what I'm using for it is I can now bright out my room. It's really changed a lot. My room was pretty dark, and now it's like I hurt my eyes. Any questions?
Other ones?
All right, thank
All
you.
right, good job.